What are the key components of a sensory neuroprosthetic system? Imagine a device that can help you feel what you see or touch again. That's what sensory neuroprosthetic systems aim to do by connecting the nervous system with advanced technology. These systems are like bridges that restore or mimic lost senses. Let's explore what makes up these fascinating devices. First, sensors are the eyes and ears of the system. They detect external stimuli like pressure, touch, or movement. For example, sensors embedded in a prosthetic foot can measure how hard you are pressing against the ground. These sensors convert physical sensations into electrical signals that the system can understand. Next, the signal processing unit takes these raw signals and makes sense of them. It filters out noise, digitizes the data, and converts it into patterns that can be used to stimulate nerves. Think of it as translating the sensory information into a language that the nervous system can interpret safely and accurately. The neural interface is a key part that delivers electrical stimulation directly to nerves or brain areas. These interfaces can be tiny electrodes implanted near nerves or within the brain tissue. They are designed to target specific nerve fibers or brain regions to produce precise sensations. For example, high-density intraneural electrodes like the UDOS slanted electrode array are used to target individual nerve fibers for detailed feedback. The stimulator then takes the process signals and creates controlled electrical pulses. It adjusts the pulse rate, width, and strength to mimic natural sensations like touch or pressure. The stimulator acts as the conductor, orchestrating how the electrical signals are sent to the nerves. A feedback loop connects everything together. It ensures that sensory information from the environment is sensed, processed, and fed back to the nervous system. This loop helps users feel the sensations in real time, which is essential for tasks like walking or grasping objects. Power and communication modules are also vital. They supply energy to the system and allow wireless data transfer between sensors, processors, and stimulators. Usually, external devices like batteries and wireless transmitters are worn on the body for convenience. In practical use, these systems are seen in cochlear implants that restore hearing and in prosthetic limbs that give tactile feedback. For example, pressure sensors in a prosthetic foot can send signals through implanted electrodes to recreate the sensation of walking. Research is ongoing to develop artificial nerve systems that mimic how biological nerves work, making sensations more natural. Regenerative peripheral nerve interfaces use muscle grafts reinnervated by nerves to create biological feedback systems. In short, a sensory neuroprosthetic system combines sensors, signal processors, neural interfaces, stimulators, and feedback loops. This integration allows users to regain sensory perceptions lost due to injury or disease, helping them interact more naturally with their surroundings.